Good morning, students.
Good morning, ma'am.
Yes, okay, we will start. So, last class, Lena Patrino. Yes, any one of you? What we seen in the last class? Yes. In the chapter, Pato.
Basic concepts of chemistry.
Okay, some basic concept of chemistry. We finished the problems. I think all the concepts are covered. Okay, let's move to the next lesson, structure of atom. Okay, so what is the structure of atom? Atom structure. What is it? Which shape it is?
Spherical, ma'am.
Very good. It is spherical shape. Okay. And what are the subatomic particles?
Electrons, protons.
Electrons, protons, and neutrons.
Very good. Electrons, protons, and neutrons. See, first in the book, it was given that history part, like who found that electron, who found that proton, everything. Before that, we will learn the basic concept, like how to write the electronic configurations, all those things. Then we'll come to the about the how to find the electrons, like how the scientist has found the electron, and then proton, and then neutron. Okay, or everyone know how to write the electronic configurations?
Yes, ma'am.
Okay, based on AFBA principle, like 1s2, 2s2. Yes, students, are everyone know? Okay, let's see that.
Yes, ma'am.
Very good, very good. Okay, what does mean by atomic number? Yes. Let's say sodium. What is the atomic number of sodium atom?
11.
11. Very good. What it is denote?
It has 11 electrons.
Very good. It has 11 electron. What about the proton count?
It's also 11, ma'am.
Very good. It is also 11. Okay, yes, we will see all the definitions. See, in the structure of atom, we know the atomic, like the atom of a structure which is spherical shape, right? The atom of the structure of atom is a spherical shape. Okay, and what are all the subatomic particles? Subatomic particles are
Electrons,
protons, and then neutron. What is the charge of electron?
negative charge, ma'am.
Very good. It is negatively charged particle, and the protons are
Positively charged.
very good. It is a positively charged particle, and neutron,
They don't carry any charge, ma'am.
yes, no charges. Yes, perfectly right. And the electron, the symbol is negative, proton is positive. Like this is a way we will simply say electron. We no need to write ELET. So instead we can write E minus P plus and then neutron. So no charges. So these are all the subatomic particles in the atom. Okay. Now, so the shape of an atom is sphere. Where the proton is located? Tell me.
Protons and neutrons are in the center as nucleus, ma'am.
Very good. So protons and then neutrons are in the center, right? Okay. Then where the electron is located?
Around the protons and neutrons, it's constantly revolving, ma'am.
Okay, it is continuously revolving. Okay, electron minus. We can say electron is present in the orbit and protons and the neutrons are in the center of the atom, right? So what is the center of atom called as?
The nucleus, ma'am.
Very good. That is nucleus, right? Exactly right. This is nucleus. Okay. So where the protons and neutrons are placed means in the nucleus. So nucleus is a position where the electrons and protons present. Okay. Here I am meaning the red color as a protons, P plus, and this is a neutron. And electrons are present in the orbit, which is continuously revolving in the orbit. So if you see this type of a pattern, like to which you will relate. This is exactly relate to what? We can relate to solar system, right? Like how the sun is in the center and the planets are revolving. Similarly, the protons and neutrons is in the center and electrons are revolving. The electrons are considered as the planets. Clear, students? Is there any doubts? Okay, fine. See, now let's come to the shell. Shell, it is E minus, like K shell, M shell, N shell. We know that, right? What does in K shell mean? What is the order? Like K shell is a first shell, second shell, or third shell? It contains 2 electrons. Very good. K shell has 2 electrons. Exactly right. What about the L shell? Yes. How many electrons are in the L shell? Yes, students. Okay. See, we have a formula for that. The maximum number of electron in shell can be calculated. What is the formula?
2n square.
Very good. Can be calculated by 2n square. Okay, by 2n square. So if you substitute n value equal to 1, n here denotes shell number, okay, or orbit number. So if orbit number is 1, then substitute in the 2n square formula, you will be getting 2. So the maximum number of electron in the first shell is 2. So let's move to n value equal to 2. So which is L shell, right? N value is equal to 2 and which is L shell, and this is K shell. So substitute again n value equal to 2 in the formula, 2 of 2 square, which is how much? 8. So similarly you have to calculate for n value equal to 3 and 4. So the first shell can hold maximum of 2 electron and the second one can hold 8 electron and the third one has how much in third one? 18 electrons.
18
right?
electrons.
Very good. 18 electrons. This is the way we will arrange the electrons. Okay. Then let's come to what is nucleons? Have you heard about nucleons? What is mean by nucleons? Yes? Nucleons is nothing but simply protons and neutrons. Okay, protons and neutrons are called as nucleons. Protons and neutrons together called as nucleons. Okay, now let's come to atomic number and mass number. You have an idea already about atomic number. Atomic number usually you will be writing in the subscript, and then mass number. What is a mass number? Mass number for sodium?
23.
Okay. What it is mean? What is a mass number? Atomic number, someone said it's a number of electron. Okay. So is it a number of electron, atomic number?
Yes, ma'am.
Okay. Mostly we will be denoting here number of proton. Number of proton is the first preference. Okay. Then only you have to say number of electrons. Okay. So sometimes atomic number is, it is always number of protons or number of electron only if it is neutral atom. Only if it is neutral atom. This is very, very important. Okay. See, don't say number of electron always. Atomic number will not be equal to the number of electron always. Only atomic number is equal to the number of proton. So sometimes it will be equal to the electron also, but the condition is the atom should be neutral. What is mean by neutral, students?
The charges are balanced, ma'am.
Very good. The charge is balanced. What does it mean, charge is balanced?
The number of protons equals to the number of neutrons.
The number of proton is equal
I mean
to
electrons, ma'am. Number of protons equals to number
yeah,
of electrons.
correct. Yes. The number of protons should be equal to the number of electrons. because the protons are positively charged particles and neutrons are negatively charged particle. You have an equal number of in the set. You have an equal number of protons and electrons means then definitely the charge is balanced and it is a neutral atom. Okay, yes, so very good. This is an atomic number. It's not only a number of proton, not number of electron. If it's a neutral atom, then we can say it's a number of electron. Now let's come to mass number. What does it mean by mass number?
Proton and neutron.
Very good. Sum of proton and neutron. Proton and neutron. Yes. Okay. So now let's take a sodium. The sodium atomic number is 23. Okay. So now tell me how many neutrons are present in sodium? So which is a proton plus neutron. Yes. Tell me the neutron count in sodium. Mass number is 23. Proton count is 11. Anyway, we know because atomic number is given. Yes. Then we don't know the value of n. So 23 minus 11, it should
12.
be 12. Very good. So this is the way you have to calculate the neutron. Okay. Yes. So sum of the proton plus neutron will be your mass number so that you can calculate the value of neutron. Okay. Very good. Yes. Is there any doubt so far, students? Are everyone clear?
Yes, ma'am.
Yes, ma'am.
Okay. Yes. So what is a protons and neutrons together called as?
Nucleons.
Very good. It is a nucleus. Nucleons. Where the protons and neutrons are located?
Center.
Center of the atom, which is?
Nucleus. In the nucleus.
Very good. In the nucleus. Okay. For example, the atom is donating electron. Okay. Then is it becomes a positive ion or a negative ion?
Positive.
It become a positive ion, not a negative ions. See, let's take an example. Sodium. You have an 11 atomic number and this is a neutral atom. Neutral atom means no charges given. Okay. Some charges are given means then you have to say ions. Okay. Now this is a neutral atom. Okay. Neutral atom. We know that neutral atom has equal number of protons and electrons. Very important. Neutral atom has equal number of protons and electrons. Okay. Sodium 11. So 11 electron and then 11 proton. Right. Now this atom is donating one electron. Okay, it is donating one electron so that Na still the atomic number is 11. There is no change. But it is donating one electron means how many electrons we have now?
10, ma'am.
Very good. 10 electrons. How many protons we have now?
11, ma'am.
Very good. 11 proton. And tell me what is the charge of the proton? Charge of the Na? What is the charge? Very good. Plus 1. That is Na plus 1. Why we are writing Na plus 1? Why it is in plus 1 charge?
Because it's a cation and it lost an electron, so it's positive.
Very good. It is in cation. Whenever an atom losing its electron, then it forms a cation which is positively charged particle, right? So positively charged means which is cation. Okay, cation is a positively charged particle. Na plus 1. Okay. Why it is an Na plus 1? Very simple. You see the charges. Who is excess? Electron is excess or proton is excess?
Proton, ma'am.
Proton is excess. So how many number of protons are extra?
1.
That's the reason it is Na plus 1. Okay. So whenever an atom losing its electron, the increase in that is not increase in the proton charge. The proton charge is extra than the electrons. So of course it will have a positive sign. Okay. That is the reason it is Na plus 1. The same way we will do it for aluminium. What is the atomic number of aluminium? Yeah, atomic number of aluminium?
13, 13, ma'am. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13. 13.
How many electrons and how many protons are there?
13 electrons and 13.
Protons.
Very good. 13 electrons and then 13 protons. Suppose the aluminum is losing 3 electrons. Okay, 3 electrons. So 3 electron is it lost. Okay, then how many electron it has now?
10, ma'am.
10
10
electrons.
electrons.
Very good. And the proton count still remains same, which is 13 protons.
13.
Okay. So now, what is the charge of this aluminium?
Al3 plus 2.
Al plus 3, ma'am.
Very good. Al plus 3 or Al3 plus, whatever it is, it becomes Al3 plus, right? Okay. Because who is excess? Proton is excess.
Proton.
And how many protons? There are 3 protons.
3
So
protons.
which is Al3 plus. Exactly right. Then we'll move to oxygen. Okay, oxygen. Atomic number of oxygen is
8, ma'am.
8, ma'am.
very good. Very good. Atomic number of oxygen is 8. Okay. So then it has an 8 electron, then 8 proton. Suppose it is accepting 2 electron. Okay, which is gaining electron. So then how many electron the oxygen has now?
10, ma'am.
Very good. 10 electron. Again, still the proton count is same. The proton count will not vary atom to atom. Okay, like, sorry, not atom to atom, like the same atom has same number of proton. So the proton will not gain or the proton will not lose. So the proton count remains same. That's the reason we are comparing the atomic number with the proton always. Okay, it is a 10 electron and then 8 proton. So who is excess now?
Electron.
How many numbers are excess?
2.
Okay, then the charges oxygen.
Minus 2, ma'am.
Minus 2.
Oh,
Very
minus
good, very good. So oxygen minus 2. So this is a way you have to calculate. Very good. This is right. Okay, now we have one more thing. Why the sodium is losing 3 electron? Why the sodium is losing 1 electron? Then aluminium is losing 3 electron. Oxygen is gaining 2 electron. Why? Why the numbers are vary from one atom to the atom?
Because of bonds.
Set, ma'am.
Because of
Bonding, ma'am.
Ma'am,
because of bonding. Okay.
ma'am, it should be octet, ma'am. That is completely filled and it should be stable enough.
Very good. It is because of the octet configuration. So, for example, let's take sodium. The atomic number is 11. So, how we will arrange the electrons?
1 is 2.
Yeah, okay. We'll go with 1 is 2. 1 is 2. Yes, tell me, Ma. 1 is 2. Who knows? 1 is 2.
2s2, 2p6.
2p6.
Okay, first we'll come to the. Okay, I'll write this. 1 is 2. 2 is
2
2p6. 3 is 1.
Yes,
Okay, 1 is 2. 2 is 2. 2p6. 3 is 1. Are everyone clear in the Aspas principle? Otherwise, shall I teach this?
Can you teach it, ma'am?
Yeah, sure. I will teach this. Okay, so 1 is 2, 2 is 2, 2p6, 3 is 1. Now I am simply writing 2, 8, 1. Okay, we will write simply 2, 8, 1. I'll tell you in detail how 1 is to 2 is 2 comes. So 2, 8, 1. According to an atom, if atom has either 8 electron in the valence shell or nearest noble gas configurations are more stable. Okay, so the sodium, noble gas, everyone knows, right? What is a noble gas, students?
Non-reactive gases, ma'am. They
Very
are
good.
stable.
Non-reactive gases, exactly right. So everyone knows periodic table. In that, group 18. Okay, group 18 are called as noble gases, or even we can say inert gases. Inert. What is mean by inert? It is non-reactive or unreactive. Okay, that is noble gases or inert gases. So the noble gases example: helium, neon, argon, krypton, xenon. These are all the noble gases. Mostly these gases will not react because already it has stable configuration. If the atom is stable, then why it want to react with other atoms? It's not needed, right? So all the noble gases are already stable. So 90% it won't react with the other elements. Let's take an helium. The atomic number of helium is 2. The electronic configuration is 2. So now tell me, what is the maximum number of electrons present in the first shell?
2, ma'am.
2. So the helium is completely filled electrons in the first shell. So it is more stable. Okay, the atom has completely filled in the outermost shell means it is more stable. So helium has only one shell. That shell is completely filled. So helium is stable. Let's come to neon. Neon has an atomic number of 10. That means we have totally 10 electron, right? So in the 10 electron, the first shell can hold 2 electron and the second shell can hold 8 electrons. Again, if you check, the maximum number of electron in the second shell is 8. That is also filled here, right? So this is also more stable. All the noble gases are more stable because of complete electronic configuration and the outermost shell is completely filled. Okay, the last shell. This shell is completely filled. If you check here, it is 2, 8, 8. This is 2, 8, 10. This is 18, 8. Okay, so likewise everything is completely filled. So the last shell has 8 electron so that they won't react much. But if you take a sodium, so we know that sodium atomic number is 11. So it has 11 electron and then 11 proton. All the protons will be located in the center of the atom, right, which is called nucleus. Electrons are present in the orbit. But while placing the electron in the orbit, we have some rules because in the first shell, n value is equal to 1. Here, what is n denotes for? N is equal to orbit number, right? N value equal to 1 means the maximum number of electron is 2 and n value is equal to 2 means the maximum number of electron is 8. N value is equal to 3 means which is 18. Okay, these are all the maximum number of electron. Now, let's take a sodium. We have placed 11 proton in the center. But how do we arrange this 11 electron? Okay, the first, let's take this is in first orbit. Okay, first orbit. What is the maximum number of electron in the first orbit? 2. Okay, so we are placing 2 electrons in this first orbit. Okay, because the first orbit has 2 seats, only 2 seats. The 2 seats are filled because we have 11 electrons. The first 2 electrons filled in the first orbit, and the second orbit has 8 seats. So now I am placing the 8 electrons. So it is 2, 8. So how many electrons you have totally filled in sodium?
10.
10,
10
ma'am.
electron. So how many electrons are remaining?
1.
Yeah, still we have to place one more electron. So like 1, 2, 3, 4, 5, 6, 7, 8. I have placed 8 electron in the second orbit and this is in third orbit. So third orbit, let's take. The third orbit can hold maximum of how much electrons?
18 electrons.
18 electrons. But how many electrons we have?
1, ma'am.
1.
1. Shall we place the 1 in the third orbit? Yes or no? Okay, so we can place a third electron in the, like the last electron in the third orbit. It's not mean that the third orbit should has 18 electron. The maximum level is 18 electron. Even if you have lesser than 18 electrons also, you can place it in the third orbit. Okay, so now the third orbit has 1 electron. Okay, the third orbit has 1 electron. So according to the stability part, if you take, it's 2, 8, 1. When the atom will be stable? Yes, when the atom will be stable?
It needs, it either needs 17 electrons or it can lose 1 electron, ma'am.
Very good. It simply we can say octet configuration. Octet configuration in the sense 8 electrons in the outermost shell. Okay, here it is 2, 8, 1. So 2, 8, 1 in the sense either last shell should be 8 electrons. Otherwise, we have to make the previous shell to be 8. Okay, so for example, you have a 2 comma 8 comma 1 configuration. I want 8 electrons here. So what is the possibility? How you will make this 1 into 8 electrons?
By gaining 7 electrons.
Very good. By gaining 7 electrons. Okay. So otherwise, I can lose this 1 electron. Okay. So minus 1 electron. So that this 1 will completely goes away. So again, my new configuration is 2 comma 8, which is an easier process. Gaining 1 electron or removing 1 electron?
Removing.
Very good. Removing 1 electron is an easier process, right? Of course, we will select the easiest pathway. Same way, the atom is also will select the easiest pathway. Okay, what the sodium is doing? The sodium is removing 1 electron to become an octet configuration for its stability. Okay, for the stability purpose, it is removing its 1 electron. So now the sodium has 10 electron. Okay, 10 electron having a configuration of 2 comma 8. Okay, that's the reason it is Na plus 1. It is for simply stability. Are you people clear? Is there any doubt?
Yes, ma'am.
Yes, ma'am.
Okay, yes, fine. Then one more thing here we have to discuss about the metals and non-metals. What is the character of metals and non-metals? You have learned in the lower classes. Characters.
Physical properties, ma'am, or chemical properties?
Yeah, you tell me what are the things you know about metals?
Metals, they are mostly forming ionic bonds,
Super.
and their physical properties are that they are ductile, malleable.
Exactly right. Ductile, malleable, sure. We can say all these properties and conductors. Yes, these are all the important properties. If you talk about the character of the metals are electropositive. What is a metal character? The metals are electropositive in nature. What does mean by electropositive? Yes, students. What does it mean by electropositive?
They need more electrons, ma'am.
No. They will donate electrons. Always metal will donate electrons. It won't accept electrons. Wherever if you check, the metals will always donate electrons. Okay. Electropositive in the sense metals are very good. They will always donate whatever it has. Okay. The metals will donate its electron and it will turns into what charge? Positive charge, because whenever an atom donates electron means it is in positive charge, also called as cation. Okay. Remember, all the metals will donate electrons. Clear, students?
Yes, ma'am.
Okay. Yes. Now let's come to the non-metals. Okay. What is the character of the non-metal?
They are not very good conductors of electricity.
They are not very good conductors. They are not sonorous. They are not malleable. They are not ductile. So we can say that point. So you think relative to the electropositive nature and tell me. So of course the metals are electropositive. It should be an just opposite, right? So what it be?
Electronegative.
Very good. It is an electronegative. Non-metals are electronegative. What does mean by electronegative?
It gains electrons.
Very good. It gains electrons. Okay. Mostly gain electrons. Here I can't say 100% non-metals are gain electrons. Sometimes it will vary. Okay. Mostly it gains electron. So gains electron means it becomes a negatively charged particle, and of course it will form an anion. Okay. It becomes anion. Yes. Now let's go for one simple example of non-metals. Let's take nitrogen. What is the atomic number of nitrogen?
7, ma'am.
Very good. Very good. Atomic number of nitrogen is 7. Let's write the electronic configuration. What is the maximum number of electron in the first shell?
2.
2.
Very good. Very good.
2, ma'am.
It is 2. And the second shell has
5.
5. Okay. So either the nitrogen should donate the 5 electron, because so that the first shell is completely filled, it becomes stable. Otherwise, the nitrogen has to accept 3 electron, either minus 5 electron or plus 3 electron. So which is an easier path?
Plus electrons.
Plus 3 electrons. So this is an easier path. It will not mostly prefer to donate minus 5 electron. The easier path is plus 3 electron. So if this nitrogen is gaining 3 electron means now it has a 7 electron. So if it gains 3 electron means it becomes 10 electron. So how many electrons are excess? 3 electrons. Then what is the charge of nitrogen?
-3.
Very
Minus
good. Yes, exactly right. It is -3. Clear, students? Because nitrogen is a metal or a non-metal?
non-metal.
It's a non-metal. So non-metal will mostly accept electron. So wherever the metal 100% donate electron, but the non-metal either accept electron or donate electron. But 90% it will accept electrons. It depends upon the atom is bonded, the non-metal is bonded to which atom. Okay, it's depend upon that. We will discuss that in detail. Now clear, right? Is there any doubt so far, students?
No, ma'am.
Okay, fine. So now I'll give you some examples. Tell me the electronic configuration of this sulfur. Atomic number 16. Tell me the electronic configuration.
2,
1s2, 2s2, 2p6.
Yeah, we will go with the 2 comma. We will go ahead with the 2 comma.
8,
2 comma 8
8,
comma
6.
Very good. Because first shell can hold 2 electron, the second one can hold 8 electron, and remaining electrons are 16. So already you have filled 10 electrons. So 2 plus 8 is 10. So already 10 electrons I have filled. The remaining electrons is 6. So I am placing in the third orbit. The third orbit can hold 18 electrons. Maximum electrons in the third orbit is 18. But we have only 6 electrons. So we are placing the 6 electron in the third orbit. So one more. What? Yes, let's move to argon 18. Atomic number is 18. Argon.
2, 8, 8.
Very good. Simple. 2, 8, 8. Just I'm adding extra 2. 16 is here. Then this is 18. So simply add 2 electron in the last orbit. And this is 2, 8, 2. Okay. Then one more important one. What is mean by valence shell? What is mean by valence shell?
the outermost shell, ma'am.
Very good. Outermost shell. Very good. This is important. Valence shell in the sense outermost shell. Then what is mean by valence electron?
The number of electrons that are there in the valence shell, ma'am.
Yeah, that's all. So valence electron is electrons in the number of electrons in the outermost shell. Number of electrons in the outermost shell or orbit. Okay. So now tell me, what is the valence electron in sulfur?
6, ma'am.
Very good. 6 is the answer because valence shell is a sixth, like third orbit. Third orbit is the last shell. How many electrons in the last shell? 6. Right. So that is your valence electron. Either you can say outermost electron or even valence electron. Both are correct. Then one more example. Let's go with magnesium. Atomic number is 12. Yes. So tell me the electronic configuration.
2, 8, 2.
Very good. It is 2, 8, 2. And what is a valence shell?
2.
2 is the valence.
You're not supposed to say 2. Okay, the valence shell is third shell, right? Valence electron means you have to say 2 electron. My question is valence shell. Third shell is a valence shell. Am I right or wrong?
Yes.
Yes, ma'am.
Okay, so if the question is about valence electron means say how many electrons are in the valence shell. Valence shell means you have to number the shell, which is 1, 2, 3. So third shell is my valence shell. Otherwise, this is K shell, L shell, M shell. If fourth shell is there means this is N shell. So now tell me in the alphabet form, what is a valence shell for magnesium?
M.
M shell. Very good. M shell is the valence shell. The first shell is denoted as K. Second one is L. and the third one is M, and the fourth one is N. Okay. Now, let's come to potassium. What is the atomic number of potassium?
19, ma'am.
Very good, 19. Now tell me the electronic configuration for potassium.
2, 8, 8, 1.
Very good. 2, 8, 8, 1. Okay. So here we have a confusion. Why means because the third shell can hold how many electrons?
18 electrons.
But here we are placing only the 8 and the fourth orbit has 1 electron. Why? What is the reason? It should be 8, 2, 8, 9. No. Why we are placing like this? Why it is 2, 8, 8, 1?
Because the atom, if it's 2, 8, 9 is in the excited state, and then when it's normalized, it is rearranged like this, ma'am.
Okay, so we can say that if electrons having an like the outermost having an 8 electrons means it is more stable. Even if you check here, it is 1. So it is not that outermost electron is also not 8. Is there any other answer, students? It's not a right answer, but somewhat right. Is there any other answer? Yes? Okay, calcium if you check, even it is also 2, 8, 2. Okay, it is not 2, 8, 10. Okay, it's 2, 8, 8, 2. Why means now here we have to check the Aufbau's principle. Based on the Aufbau's principle only, the electronic configurations is differing here. So let's see Aufbau principle. See, what is 2, 8, 1? What is the difference between the 2, 8, 1 and 1s2, 2s2, 2p6? How can we relate these two? Both are electronic configuration, but one we are representing in 2, 8, 1. The other one we are representing as 1s2, 2s2, 2p6. What is the difference in this? Yes? See, this is based on shell electronic configuration. What is this? Shell electronic configuration. In a particular shell, we have this many number of electrons. The next one, the Aufbau principle is about subshell electronic configuration. Okay? Yes. See? S, P, D, F. What is this called as? They are subshell. What is this SPDF? Students, am I audible?
Yes, ma'am.
Yes,
What
ma'am.
is this SPDF called as?
Subshell.
Yeah, subshells. Okay. So what is the maximum number of electron in the second orbit? Second shell?
8.
8 electrons.
8 electrons. It is 8 electrons. So you have a maximum number of 8 electron in the shell, right? Similarly, you have a maximum electron in the subshell also. See, if you are zooming, just imagine an atom in your mind. You are zooming. If you are zooming, you can see the electron, proton and neutron. And again, if you zoom further, the electrons is present in the shell. If you further zoom, electrons are present in the subshell. Okay, we are just zooming in, zooming in, zooming in. That's all. Okay, we have a shell. If you further zoom in, you have a subshell. Okay, so now how many electrons are in the s orbit? S subshell, maximum electrons are 2. For the p subshell, the maximum electron is 6. For the d subshell, the maximum electron is 10. For the F subshell, the maximum electron is 14. Okay, these are all the maximum number of electron in the particular subshells. Okay, yes. Now let's come to Aufbau's principle. So before to know the how to write the electronic configuration based on the subshell. Okay, we are writing 2, 8, 1. 2, 8, 1 means this is an electronic configuration based on the shells. Okay, I am writing 1s2, 2s2, 2p6 means this is based on the subshells. That's all, very simple. So for that, we have to know Aufbau's principle. Very simple. Half-bars principle. Just you have to follow the lines. A kind of snake diagram. Very simple. 1s2, then 2s2. The diagram should be exactly like this. Don't put the numbers. 1s, 2s, 2p, then 3s, 3p, next to 3p, it is 3d, then 4s, 4p, 4d, and then 4f. Again, we have only till f. Okay, so the first shell has only S subshell. The second orbit has two subshell, which is S and P. The third orbit has SPD subshells. And the fourth orbit has SPDF subshells. And the fifth one has 5S, 5P, 5D, 5F. So I think till this is enough. We don't need to go till 7F. We will first complete this. See, just follow the lines, okay? Then it is very simple. What is an half-bars principle? Here, the electrons are arranged based on the energy level. Electrons are arranged in increasing order of energy level. Increasing order of energy levels. Are you clear, students? What is an half-bars principle? Why we are moving an half-bar principle?
Electrons are arranging in increasing energy levels.
Very good. Increasing energy levels. Exactly right. See, half-bars principle is used to find out the electronic configuration based on the sub-levels. Okay, based on the subshells. So you follow this. The lowest energy is for 1s. Next to 1s, it comes to 2s. Next to 2s, it has to move to 2p. Next to 2p, it comes 3s. Next to 3s, it is 3p. Next to 3p, it is 4s. After 4s, it is 3d. Next to 3d is 4p. Then 5s. Okay, here I am completing till 5s. So I think we don't need to go till 7s. This is enough for us. So 1s, first orbit is what? Your 1s, right? So 1s, next to 1s, I am going to 2s. Just follow the lines, okay? Next to 2s, I am moving to 2p. Next to 2p, I am moving to 3s. Next to 3s, it is 3p. And next to 3p, it is 4s. After 4s, it is 3d, then 4p, then 5s. Okay, this is an order to write the electronic configuration based on the subshells. Now, let's write for hydrogen. Atomic number of hydrogen is 1. So, it has an 1 electron. Based on the shell electronic configuration, you will write simply 1. Because we have only 1 electron, the first orbit can hold 2 electrons. So, I am placing my only 1 electron in the first orbit. In terms of subshells, so where I have started, from where I want to start?
1s.
1s, very good. What is the maximum number of electron in the 1s?
2, ma'am.
Yes,
2.
all the sub S has maximum of 2 electron, right? So I have only 1 electron. So the electronic configuration is 1s1. Okay, the very important, what is this 1 denotes for? This 1 is your orbit number. Okay, what is this 1 denotes for? Your orbit number. What is an S here? Your subshell.
Subshell.
Very good. Your subshell. What is this 1 denotes?
Number of
Number of-
electrons.
Very good. This is your number of electron. Exactly right. So the 1 is your sub orbit number. S is your subshell, and this 1 is your number of electron. Okay, very simple. Now I'll go with the nitrogen. Atomic number of nitrogen is 7. There are 7 electron. Based on the shell, we will be arranging 2, 5. Okay, now let's come to the half-bars principle. So I have to start from 1s. Okay, there are totally 7 electrons. So 1s. So the 1s can hold how many electrons? 2
2
electrons.
electrons.
So again, I'm moving to 2s because just follow the lines 2s. How many electrons can be in the 2s? Again, wherever yes, it is only 2 electron. No. So it is again 2s2. Okay, so totally 4 electrons you have filled now for nitrogen. How many electrons are still remaining?
1.
No. We have 7 electrons, right? Only 4 electrons we have filled. So 3 electrons we have still now. Right?
Yes, ma'am.
Okay. So just follow the lines. Come to 2s and 2p. So what is the maximum number of electron in the p subshells?
6 electrons.
Very good. 6. Then shall I place a 3 electron in the p subshell? We can place it, right? Because the p can hold of 6 electron. But we have only 3. I am placing the remaining 3 electron in the p subshell. So it is very simple. It is 1s2, 2s2, 2p3. Clear, everyone? Is there any doubt, students?
No, ma'am.
Okay. So it is 1s2, 2s2, 2p3. We will try for the some other atom. Let's take sodium, atomic number 11. Okay, atomic number 11, it has an 11 electron. Based on the configuration, it is 2, 8, 1. See, remember, you have an 11 electrons. You have to fill the 11 electrons based on the Aufbau's principle. So now tell me where I have to start. I have to start from
1s.
1s. Very good. So in the case of 1s, it is 1s. What is the maximum number of electron in the s
2
subshell?
electrons.
Very good. It is 2. So it is 1s2. So next to 1s, where I have to move
2s.
2s. So again, what is the maximum number of electron in the s
2
subshell?
electrons.
2. So it is again 2s2. After 2s, I have to move to
2p.
2p. What is the maximum number of electron in the 2p?
6
P
electrons.
subshell 6. Okay, now I filled 6 electron. Just count at this stage. Okay, I have 2 electrons here, 2 electrons and 6 electrons. So totally I filled 10 electrons.
10
How many
electrons.
electrons are remaining? Because we are filling for sodium. The atomic number of sodium is?
1 is remaining.
Yes, we have only 1 electron. Where the 1 electron will go? You are complete 3s. Very good. So the 2p is I'm filled, right? So next to 2p, it is an 3s. So it should be 3s, 2 or 1?
1.
3s, exactly right. It is 3s 1. So this is a way we have to complete the electronic configuration. Is it easy or how many of you has doubts, students? How many of you have doubts till now? Okay, so sodium electronic configuration is 1s2, 2s2, 2p6, 3s1. I'm just going with this order and I'm getting this configuration. So now I'll fill it up here. 1s2, 2s2, 2p6 and then 3s1. So what is this? Let's take a 3s1. What is this 3 denotes for?
Third orbit.
Very good. Third orbit. And what is this? Yes.
Subshell.
What is this one?
Number of electrons.
Number of electrons. So simply if you count the number of electrons, make sure that it should be equal to your atomic number or the number of electrons. So as I have 11 electrons here, it is 1s2, 2s2, 2p6, 3s1. I have an 11 electron. The power should be equal to the number of electrons you have. Very good. So now if you check, this is an 1s2, first shell. So first shell has how many electrons?
2 electrons.
2 electron. And this is also second and this is also second. I know that this number denotes a orbit number or shell number. So these two. Let's count the number of electron in the second orbit. How many?
8 electrons.
Very good. 8 electrons. So let's take the third orbit. The third orbit has
One
only one
electron.
electron because there is only one subshell, 3s1. This has 3. So now this is and this one both are same. Am I right?
Yes, ma'am.
2 comma 8 comma 1. This is just for your understanding. I wrote this 2 comma 8 comma 1. So we are just zooming in and we are writing the subshell. Even if you are further zoom, we have actually orbitals. Okay, that we will learn in the next class. Okay, now I'll give you for potassium. Potassium atomic number is 19. So 2 comma 8 comma 8 comma 1. Total number of electron is 19. So here only we have to solve why this is 2 comma 8 comma 8 comma 1. Why it is not 2 comma 8 comma 9. Okay, this is based on the Aufbau's principle. Okay, yes. Will you people try? Tell me how we will arrange the electrons here for potassium.
1s2.
Everyone, I want to say everyone, only one person is responding. Yes, students, everyone. Potassium starts from 1s.
2s2, 2p,
Very good. 1s. So 1s2, 2s2,
2p6,
2p6,
3s2,
3s2. After 3s2, just count. We will count because 2
3p6,
plus 2, 4, 4 plus 6, 10, 10 plus 2, 12. I have totally filled 12 electrons. Still I have how many electrons remaining? 7 electrons, right? Because we are doing for 19 electron. So 1s2, 2s2, 2p6, 3s2, 3p6. So next to
3p6.
4s1,
4s1.
very good. So for my 19 electron, I've selected. For 19 electron, I'm getting 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Is there any doubts in the half-pass principle, students? Are everyone clear?
Yes, ma'am.
Clear? How many of you have doubts? Okay.
Ma'am,
Yes?
what is the maximum number of electrons in the F subshell, ma'am?
Yes, subshell can hold only 2 electrons.
F.
F has 14, 1 4.
Thank you, ma'am.
Okay. So here I'm doing for potassium. So we got 1s2, 2s2, 2p6, 3s2, 3p6, and then 4s1. I think this is what we got previously. Am I right?
Yes, ma'am.
Okay, so if you check here, so this is a first orbit, and this is a second orbit, this is your third orbit, and this is your fourth orbit. So how many electrons in the first orbit?
2 electrons.
How?
8 electrons.
8 electrons, because I have to sum up the electrons which is in the second subshells. So which is 8, and then in the third subshell has 3 plus 6. Sorry, 2
8
plus
electrons.
6, which is again 8 electron, and next it comes to
1 electron.
4s, again it is 1 electron. So you are getting the same. Am I right or wrong?
Yes.
Right, ma'am.
Yes. Okay. Yes, that is a reason. According to the subshell configuration, I am getting 2 comma 8 comma 8 comma 1. Only this is a case. Okay. So if you check here, what is the problem? Why it is not again 9? Why it is 8 comma 1 means actually next to 3s and 3p, we have to fill the 3d electron, right? So next to 3s, because here 1s is filled, then 2s, 2p. So 3s, 3p is filled. Next, I have to fill the 3d electron. But I am moving to 4s, right? We are not filling the 3d electron first. We are filling the 4s, then only we are coming to 3d. Am I right or wrong, students?
Right, ma'am.
Yes. Why? Why we are filling the 4s electron first and coming to the 3d next? Because
Because energy level.
right, exactly right. because Aufbau's principle is based on the energy level. If you take the energy level of 4s and 3d, the 4s is having a lower energy. That's the reason you are filling the 4s electron first and coming to the 3d. Clear? That's the reason and the difference. So 2 comma 8 comma 8 comma 1. Okay, you are not filling the electrons in the 3d, you are filling the electrons in the 4s because the 3d energy levels are greater. Now understood, right?
Yes, ma'am.
Yes, okay. Now let's come to the isotopes. Isotopes and all you have learned already. Yes. What is an isotope, students? Same atomic number.
But different mass
Different
number.
mass number.
Very good. Same atomic number and then different mass number. We did in average atomic mass also, right? Same atomic number and then different mass number. Will you give me some example for this?
8 was 16 and 8 was 17. Oxygen 16 and 17.
Very good. Oxygen has isotope. Atomic number is 16 and the mass number is atomic number is 8 and then mass number is 16 and then for other oxygen atom you have a mass number is 17
17.
and then here it is 8. What is the difference in this mass number? Why the mass number are varying here? What is the reason? Mass number constitute? Yes, students?
Proton
What
plus
is-
neutron.
Yes, sir. So mass number is actually a proton plus neutron. Am I right? Okay, let's take both the oxygen atom. I want you people to calculate the number of neutron, proton, and then electron. Tell me in both the cases. Tell me the calculate proton, neutron, and electron in both the cases.
In first case, neutron is 8. Proton and electron also 8.
Okay, so as the atomic number is 8, and this is also a neutral atom because here I didn't mention any charge, it's a neutral atom. So proton is 8 means there is no doubt even the electron is also 8, right? In the next case, atomic number is 8 and still it is a neutral atom. So here also 8 and here also 8. But the mass number is 16 and here it is 17. If you calculate the neutron here, this is an 16 and the proton is 8. So definitely the neutron should also be 8. Okay, then only it will be 16. So neutron is also 8. But in the second case, so here it is an 17. Proton count is 8. But the neutron count should be 9. Am I right or wrong? It should be 9. Okay, then who is different here in the isotope?
Neutron.
Yes, so same atomic number but different mass number. Why it is a different mass number? It's due to difference in neutron count. Am I right? It is due to difference in neutron count. Okay, very simple. So protons are always same, even electrons are always same in the isotope. Only the difference is neutron count. The neutron count is vary in the isotope. Okay, now let's come to isobar. Okay, what is the next one? Isobar. I think this also you people learned already. What is an isobar?
Same mass number but different atomic number.
Okay, exactly opposite of the previous one. Same mass number and then different atomic number. Different atomic number. So example, if the atomic number is different, then there is no doubt the elements are also different. If the atomic number is same, then the elements are same. So examples, you can just simply note down the example. Carbon 14 isotope and then nitrogen 14. So here the atomic number is different, but mass number is same. This is for isotopes. Then you have an isotones. What is mean by isotones?
Same neutron number.
Same neutron number, right? Very good. Same neutron number. Same neutron number atomic number is different. Okay, atomic number is different. So atomic number is different and then same number of neutrons. Examples, carbon again 16 and then 13, nitrogen if you check 7 and then 14. Even the mass number is also different, students. You can write down that point also. Mass number is also different. Atomic number is also different and then mass number is also different. Only the same number of neutron. So if you calculate the mass number, sorry, neutron number here, both will be 7 and 7. Okay, the neutron count. This is neutron. So neutron will be 7 and 7 here. Okay, this is called as isotope. Same neutron number but different in the atomic number and mass number. Is there any doubts, students?
No, ma'am.
Clear? Everyone clear? Okay, I'll give you one question. Tell me the electronic configuration of this one. You can refer the half-bus principle. I think I'll take the half-bus principle. One minute. Let's see. Okay, tell me the electronic configuration based on the subshells for vanadium, scandium, titanium, vanadium. Atomic number is 23. For all the competitive exam, it's mandatory to memorize the first 30 elements with the atomic mass. Okay, so memorize the first 30 elements with the atomic mass. Vanadium atomic number is 23. I want everyone to do it in your note. Finished? Do it in your note and tell me. Finished, students? Yes. What is an atomic number? 23 is atomic number. What is an electronic configuration based on the subshells? Yeah, who is ready? Tell me.
Ma'am, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d3.
Very good. 3s2, 3p6, 4s2, right? 4s2, 3d3, right? It is 4s2, 3d3. So before filling the 3d electron, we have to fill the 4s electron. Okay. Yes. We have one more topic which is half filled and then completely filled. See, what is the maximum number of electron in the d subshell?
10, ma'am.
10 electrons.
Very good, 10. Half filled. Then what is mean by half filled of D?
5.
Very good. Half filled is 5. See, even half filled is also stable. Fully filled is also stable. But fully filled is more stable than the half filled configuration. Okay, students? Okay, fully filled is more stable than the half filled. Okay. So what is the maximum number of electron in the F subshell?
14 electrons.
14. So then what is a half filled configuration?
7 electrons.
So who is more stable, 14 or 7?
14.
14 is more stable because fully filled is more stable than the half filled. I want you people to do it for chromium and tell me. Chromium, the atomic number is 24. Just do the changes in the previous case and tell me. Very simple, right? Just do the changes here and tell me. Tell me only these two shells because remaining all these are same. This is exactly the same, right? Tell me this alone.
3D4 மாறிடும்.
3D4, very good. 3D4 மாறிடும். 3D4 4s2 இருக்கும். Am I right? It should be 3D4 4s2, or else even you can write 4s2 3D4. Am I right or wrong?
Yes, ma'am.
Okay, if you draw the electronic configuration according to the subshell for the chromium 24, we will be getting 3D4 4s2. This is our expected configuration. But actually what happens means, okay, so this is quite unstable, okay, because there is a 4 electron, right? So we know that half filled and completely filled is more stable, right or wrong? So what the chromium is going to do, the chromium is borrowing one electron from the 4s. So now the 3D becomes what?
3 5.
Very good. It becomes 3D5. And how many electrons in the 4s?
1.
Very good. It is 4s1. For the extra stability, the 3D4 is borrowing one electron from the 4s2 so that it becomes a 3D5. So 3D5 is half filled. It is more stable than the 3D4. Okay, that is the reason this is an expected configuration, and this is our actual configuration. Okay, 3D5 4 is your actual configuration. These are all some exceptions you people have to learn. Okay, so chromium is having an exceptional configuration because of the stability purpose. It is getting one electron from the 3s. The same thing you just think and do it for the copper and tell me. Copper, the atomic number is 29. Here also there is an exceptional behavior. Think and tell me. Do it for copper and tell me.
Ma'am,
Yes.
4 and last 4 as 1 and 3D10.
Exactly right. If you write a normal configuration, you will be getting 4s2 and 3D9. Okay, like based on the half-bus principle, it will be in 3D9. Okay, 4s2 and 3D9. But what will happen? The 3D10 is more stable, no? So the 3D9 is borrowing one electron from the 4s, so that it becomes 3D10 4s1. This is an exceptional behavior for chromium and copper. Are you people clear? Is there any doubts? No?
No, ma'am.
Okay, fine. See, practice more kind of electronic configuration. In the next class, I'll ask you some questions based on this.
Yeah, I was about to ask Madam
Yes, sir.
these exceptions, but luckily you covered it because
Okay,
this
sir.
is where the smart people will be knowing all the exceptions. ரொம்ப டாப்பர்னு சொல்கிறோம் இல்லையா அவங்க இந்த எக்ஸெப்ஷன்லாம் ஞாபகம் வச்சுருப்பாங்க. ஐ ரிமெம்பர் வென் ஐ வாஸ் அ ஸ்டூடெண்ட் ஐ வாஸ் ரிமெம்பரிங் ஆல் தீஸ் திங்ஸ். இப்போ தான் ஞாபகம் வருது இதெல்லாம்.
Yes, sir.
ஸோ எனிவே தேங்க்யூ மேடம்.
Thank you, sir.
Yeah.